For section 9.4, the last section we're going to cover, we're going to look at quadratic equations in two variables. So that's back to graphing. And when you graph a quadratic equation, it's what's called a parabola. And it's kind of U-shaped. And it can open up. So that's what a parabola would look like if it was opened up. Or it could open down. Now, parabolas can be skinnier or wider, but this is the basic shape of what they look like. So we're going to walk through a few different things. The first thing is, how do you determine whether it opens up or down? So we're in the equation. If you set that y equal to 0, it's the standard form ax squared plus bx plus c. The difference is a could be positive or negative, which is different than when we were just talking about putting it in standard form to solve it using factoring or the quadratic formula. If a term is positive, it opens up. So my parabola is going to look like that. If my a term is negative, that tells me that it opens down. So that's the first piece that we look at, right? It's pretty straightforward. So for the first one, I have a 6 for the coefficient of x squared. So that opens up. For the second one, I have a positive 1 for the coefficient of x squared. So that's up. Number 3, I have a negative 1 for the coefficient of x squared. So that's down. 4, we have a negative 5. So that's down. 5, again, I have a negative 1. And then for number 6, the coefficient of x squared is 2. So that's up. So that's the easiest thing to say when you're talking about a parabola. Does it open up or down? The next thing we're going to do is find the vertex of the parabola. So the vertex, if I can go back up here, is this place where it changes direction. So if it's facing up, that vertex is going to be the lowest point it ever is. If it's facing down, the vertex is going to be the highest point the parabola ever reaches. So to find the vertex, the x-coordinate, we're using this formula, the opposite of b over 2 times a, which I hope is a little bit familiar, because remember when we were looking at the quadratic formula, what's opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So if we're just looking at the vertex, it's that first part without the plus or minus the radical. So that finds the x-coordinate. And then after you find the x-coordinate, you have to go back to the original and then plug that in to find the y. So here's our example. Y equals 2x squared plus 4x plus 1. And you have to identify a and b, because the formula is opposite of b over 2 times a. So we have the opposite of 4 over 2 times 2, which should be in there. So negative 4 over 4, which is equal to a negative 1. Now that they know what the x-coordinate is, we're going to find the y-coordinate. So this was the original equation, 2x squared plus 4x plus 1. And wherever you see an x, now we're plugging in the x-coordinate, which we found was negative 1. So 2 times negative 1 squared plus 4 times negative 1 plus 1. And that all simplifies out to a negative 1. So our vertex, where it changes direction, is at negative 1, negative 1. And also, because this coefficient of x squared is positive, I know that this parabola faces up. Alright, so let's look at this first one. We have y equals negative 2x squared minus 8x plus 18. So my a term is negative 2. And my b term is negative 8. So the x-coordinate of the vertex is the opposite of b over 2 times a. So the opposite of negative 8 over 2 times negative 2. So I get 8 over negative 4, which is equal to a negative 2. So that's the x-coordinate of the vertex. And now I need to find y. So I just rewrote the equation, but wherever I saw an x, I put parentheses. And now I'm going to go back. Since I know the x is equal to a negative 2, that's what's going to go in each of those parentheses. So negative 2 squared is 4. Minus 8 times negative 2, I'm going to get plus 16. And then that last term is just plus 18. So I have negative 8 plus 16 plus 18. And that gives me 26. So the vertex is negative 2, 26. And again, because the coefficient of x squared is negative 2, I know this thing faces down. Too many papers here, guys. Alright, we're still finding just the vertex for these. So here, my a is equal to 1. My b is equal to a negative 6. So the x-coordinate is opposite of b over 2 times a. So opposite of negative 6 over 2 times 1 gives me 6 over 2. So the x-coordinate is 3. So when I look at the y-coordinate, I'm plugging in 3 for x, and I get y equals 9 minus 18 minus 7. So 9 minus 18 is negative 9 minus 7 is negative 16. So the vertex of this is 3, negative 16. And this faces up. I know it's not asking you that, but I just want you to keep that in mind because we're going to build one more layer after this one. For number 3, a is equal to 1, b is equal to 0. So I get negative of 0 over 2 times 1, which is just 0. So plug that in for x, we get y equals 0 squared plus 16, which is just 16. So the vertex here is 0, 16, and it faces up. Number 4, a is equal to a negative 5, b is equal to 20. So we get opposite of 20 over 2 times negative 5. So I get negative 20 over negative 10, which is 2. And then the y-coordinate would be negative 5 times 2 squared plus 20 times 2. So that would be negative 5 times 4 is negative 20 plus 40, which will give us a 20. So our vertex is 220, and this faces down, because the coefficient of x squared was a negative 5. Alright, here they want us to graph it. So we have y equals x squared plus 2x plus 1. So what I know for sure is it faces up, because the coefficient of x squared is equal to 1. And then I want to find the vertex. So a is equal to 1, b is equal to 2. So opposite of b over 2 times a, I get negative 2 over 2, which is negative 1. So that's the x-coordinate of the vertex. The y is going to be negative 1 squared plus 2 times negative 1 plus 1. So that gives me 1 minus 2 plus 1, which is 0. So the vertex is negative 1, 0. And I know it faces up. I know the shape of a parabola, right? It's like that cup shape, but I need a couple more points. So what I'm going to do is find the y-intercept. So if you remember, how do you find the y-intercept for a line? You plugged in 0 for x, and that was the y-intercept. That's how you find the y-intercept for a graph of a parabola, or for any graph. You just plug in 0 for x to figure out what y is. Well, what's going to happen is the y-intercept is always whatever that c term is. If c is 0, then the y-intercept is 0. But whatever the c term is your y-intercept. So again, you plug in 0 for x, you're just left with 1. So I know it crosses at 1. And I'm going to use the fact that these are symmetric. And that just means if I were to draw a line right through the vertex, the mirror image on the left and the right would be the same. So if I have this point 1 unit over here, I'm going to have it 1 unit over here. Now you don't have to use symmetry. You can just plot points like we did for the lines, pick some x values and figure out the y's. But this is just a little bit quicker. So I'm going to use the fact that it's symmetric to get another point, and then there's my sketch.